So now we're joined by Dr. Harry Lamba, who is a California congressional candidate. He has a bachelor's degree in aeronautical engineering and then a PhD degree in engineering mechanics from the University of Illinois. And for most of his career, he has worked in industry in the Chicago area and as a materials and mechanical engineer. With the last 30 years of his career, he worked as a designer and a tester of railway locomotives. And currently, he's running for a congressional seat in California's 8th congressional district. Thank you, Dr. Harry, for joining us today. Please tell us about yourself and about your current campaign.
Yeah, actually, I ran a congressional campaign for about 7 to 8 months. Uh, but on social media, I was very active, had the whole team, had um, the registered organization, bank account, Act Blue links, everything, and a big social media presence. But when it come to, I didn't get onto the ballot
Oh, okay.
because my family situation and the finances, it was not up to the finances needed by the campaign. So I'm pretty active
But
still
you,
in the social media. My main
right.
goal was I felt that I had the ideas that uh, were for a better America. Um, I've actually on Substack proposed a 5 point economic development plan for America. It was originally in one of my other books. A part of it was in Rejuvenating America, another book that you can see on Amazon. But anyway, I was into that. I did spend about, after publishing my book that I'll share with you, I did spend 5 years trying to convince the world's political and business leaders that they should adopt a climate action plan similar to what I had proposed. Total, but wasn't very successful. As you know, political and business leaders have their own things. But what I am now telling my campaign, one of the big messages of my campaign was climate change is the biggest economic opportunity of the 21st century. You convert the United States, converts to the green and clean economy, it's going to lead the world. It can transform its economy, it can solve income inequality, it can have millions of new businesses, green businesses, it can have more plenty of renewable energy more than it needs, and it can be globally competitive, a better way to solve the trade secret than tariff wars and tariff taxes. Anyway, that's kind of the
And then
thing.
you have your
But
own solar
I can
battery
share my
project, right?
presentation with you that I
Yeah, sure.
prepared
Oh,
for
yeah.
my company, Solar Battery Hydrogen Incorporated. Should I share that?
Yes, go ahead.
Should I share my screen?
Yes.
Can you share his screen?
Um, I think you have to click on your computer. You have to click. Yep, you got it.
Can you see it?
Oh,
Can you see it?
Talk.
you can present after him.
No, it's okay.
Okay.
Can you see it?
Yes.
Okay. Should I proceed?
Yes, go ahead.
Okay. All right. So Solar Battery Hydrogen Incorporated, that's the name of my company. Um, Hydrogen on-site production, product innovation, uh, and education. So this is the only time-bound Lamba, I proposed the only time-bound, actionable plan for 1.5C for solving climate change. The book that has this is Brighter Climate Futures, and the plan also is there on the website. Um, Shota, I have 15 minutes to present this. I'll time
Yes,
it presentation accordingly.
yes,
Okay, all right. So provides plenty of clean energy. Only 2.5% of the world's of the US land area can quantitatively produce all the US energy needs according to my calculations based on the land area occupied by utility scale solar systems, but we only get 6 to 10 hours of sunlight. So what do we do? So the objective is to store this energy in hydrogen produced by the electrolysis of water using solar energy. Currently, the world is producing 90 million metric tons of hydrogen. Unfortunately, it also gives 900 million tons of carbon dioxide equivalent greenhouse gas emissions, which is the bad way to produce hydrogen. We need about 1,500 million tons of hydrogen per my plan, and this will replace gasoline and diesel. It overcomes the variability of renewable energy, uh, um, and it replaces fossil fuels. The goal of my company is basically to demonstrate solar hydrogen. I'm trying to demonstrate what I'm talking about. The hydrogen, I think it's a really good business opportunity, actually. Hydrogen fuel production using solar PV. We need to produce hydrogen at less than $36 a kilogram, which is being what is charged for Hyundai fuel cell trucks, Class 8 trucks that are being refueled at the port of Oakland in California. The federal government had set the goal of $1 per kilogram. That's going to be tough to meet, but 1 kilogram of hydrogen has the same energy as 1 gallon of gasoline. So it's the gasoline gallon equivalent. So if we can produce hydrogen at less than $4 a kilogram, it can be competitive to gasoline. So the objective was to develop expertise in all aspects of hydrogen, innovative product development. Me and my colleague, hydrogen expert, did a hydrogen basics training class October of 2024, which is on YouTube if you folks want to view that. Here's a sample of a small hydrogen generator we are developing. It basically has it's the size of a cabinet, water on top, a hydrogen tank left on the left side, an oxygen tank there, an electrolyzer down below, and a solar controller there, and the electronics. And this can produce enough hydrogen. This uses a patented regulator that equalizes the hydrogen pressure between hydrogen and oxygen parts, which is very good for the electrolyzer. And you can use lower cost electrolyzers if you can keep the pressure on the two sides the same. It's one of our colleagues' companies, cooperating companies, has a patent on it. So you use deionized water, and the electrolyzer gives you hydrogen and oxygen gases. Like I said, you have the patented regulator. This will be ready in a couple of months. My colleague is working on it. This is the way proton exchange membrane things works, where you have a membrane, a cathode and an anode, and water, and you apply electricity, and on one side you get hydrogen, and the other side you get oxygen. You can use oxygen if you want commercially, but you can also use hydrogen. So my company activities there's a big project to produce 1,000 kilograms per day of solar hydrogen, use it to refuel Class 8 fuel cell trucks. The Port of Oakland has shown an interest in this thing. If I can produce it at less than $36 a kilogram to refuel fuel cell trucks, again, it would use electrolyzers, it would use solar PV panels over a certain number of acres at the port. And if I can use it to reduce the cost of hydrogen, I can do that. And also, I engage in innovative hydrogen product development on a small scale. I have a small solar electric battery electric portable cooker, ideal for backyard or camping. It basically has two 400-watt solar panels. They can charge a 12-volt lithium-ion battery that is at the bottom of the cart, and uses a 12-volt DC electric cooker to cook food. So you can cook food during the day direct for solar, or you can cook it with the battery evening and night. This is ideal for backyard and camping, but I also had thought of having refugee and evacuation centers. So both FEMA in the United States as well as United Nations organizations could be customers for this cooker. I just filed on May 5th a provisional patent for a flameless combustion hydrogen forced air furnace. It uses a catalytic hydrogen heater that uses hydrogen gas. There's no flame involved. It combines with air to produce radiant heat without a flame. But this only heat surfaces in the room where the radiance falls. So in this patent, heat is captured on a black absorptive surface and the air is blown past it to heat the air. Similarly, one can heat hot water. So that's how we have this patent written. I'm looking for licensees for this patent, and they would have the technology protected by the patent, and then I would apply for a regular patent within 12 months. That's the rule. This was a small project I had proposed near the Port of Oakland. It was only for one fuel cell truck a day. The blue area is on the lower side is the solar panels, and then there's a transformer, and then also an office and hardware building for the hydrogen production and for the battery system. And then it would have basically a refueling center close by, which would refuel the trucks. So the larger truck project I'm talking of is 1,000 kilograms per day. Solar PV uses 10 megawatts of solar panels over 38 acres. A small battery system to keep things moving. An electrolyzer for 1,000 kilograms a day. I get cooling water from a treating water facility locally, and the refilling station would supply hydrogen either at 10,000 psi, 700 bar, or 5,000 psi, 500 bar for fuel cell Class A trucks. There's about 25 Hyundai hydrogen Class A trucks that are operating out of the Port of Oakland. But it can also provide hydrogen to other tractors and trucks, which had been, some of them are operational in some other California ports. This is an electrolyzer, and it basically has three types of electrolyzers: an alkaline that has been used for a long time, a proton exchange membrane, which is very popular but is more expensive, and then we are proposing an anion exchange membrane that is low cost, has the best efficiency, dynamic response, is modular and scalable. But anyway, we are planning to use AEM type electrolyzers. This is the way kind of it works in a block diagram. You have a solar battery or wind providing the energy to electrolyzers. You provide deionized water, and then produces the hydrogen, and the compressors compress it, the coolers cool it, and then you store this in storage tanks or transport it to the refueling station, and then the refueling station will dispense. This refueling station is pretty much, there's about 30 or 40 refueling station for cars in California, and about 2 or 3 refueling station for trucks. And more than that, maybe about 3 or 4 refueling stations for buses in California. The way
They
we
already
would
exist?
Pardon?
They already exist, you're saying?
What is the question?
These charging stations are in place already?
Yeah, that is there already. That would have been expanded a lot faster if the administration had not changed, because there was something called California, basically federal hydrogen program that was going to create 9 hubs around the country. The California hub was called Arches, Alliance for Renewable Clean Hydrogen Energy Systems, and I participated in that. But unfortunately, that did not take off because the $9 billion that was supposed to come to California was canceled by the administration. But anyway, California still has company. The California Energy Commission and the California Air Resources Board has something called the Clean Hydrogen Program. It was mandated in 2022, and it's for renewable hydrogen and to reduce greenhouse gas emissions. And the cap and trade program that is operating in California actually provides funds through the Greenhouse Gas Reduction Fund. So that's where the funding comes from. And California Energy Commission favors capital equipment investments for system producing 1,000 kilograms per day or bigger. And that's why I've sized it for 1,000 kilograms per day. This is a typical set of series of electrolyzers that are being made by a company called Nel, which is, I believe, based in Scandinavia. There's the AEM one that we want to use, made by a company called Enapter, which is a Nexus 1001. That I've talked to all of these companies, and they've given me prices, and I'm lining them up for our next conversation with the Port of Oakland. The Nexus 1000 uses 3 electrolyzers of 1,000 megawatt total capacity. They have a capacity of 1,350 kilograms per day, and the cost of the 3 electrolyzers is 8.4 million. We would, if we needed, this one actually has compressors and coolers and this thing built into it. But if we need a compressor, we can use a Howden hydrogen compressor. Hyfluence makes hydrogen refueling stations, so the storage tank would be connected to a hydrogen refueling station, and for $4 million, they can provide a hydrogen refueling station that basically your truck pulls up, they connect it, and in 5 or 6 minutes, works. The fuel cell truck is fully refueled. And by the way, that's a hell of a lot better than charging an electric truck or electric bus for 6 hours or 8 hours. And it weighs a lot less than battery systems. So the cost of battery systems can be quite high. This is a containerized one, smaller one that can be, but like I said, this one includes compressor, storage, chiller, and dispenser. Tube trailers are typically used to transport high pressure hydrogen from production sites to refueling stations. Hydrogen safety is a much safer fuel than gasoline, diesel, and natural gas, as long as it's not in a confined space. Unlike gasoline and diesel, it is not poisonous. There's no pollution, and when you use it, you produce back water vapor. Gasoline vapors and natural gas are much heavier and hang around at ground level and can cause fires and explosions. Hydrogen escapes at 40 miles per hour. The world uses hydrogen safely today at local, national, and international safeties to be complied with. The only thing to watch out with hydrogen is you don't mix it with oxygen when you store it, because you can get detonation. So you just got to keep the oxygen and air out of the connection with hydrogen when you are storing the hydrogen. That's the main safety aspects of hydrogen. CapEx prices that I've for the 1,000 kilogram a day electrolyzers be about 8 million, the refueling station about 4 million. The hydrogen CapEx is 14 million. Renewable energy supply would be about 20 for 10 megawatts, about 20 million dollars. We can have a contractor lined up to do it at a reasonable cost. If the 30% tax credit is available, then it only costs 14 million. Similarly, the battery system of about 3 million would cost only 2 million. It would be about a 2 megawatt battery, lithium ion battery system. We do need engineering, transformer, construction. I'm estimating it for $2 million. So I would be asking the California Energy Commission for a funding as much as they can of a project that would be 32 million. If the CHP funding, California hit, they usually fund quite decent amounts. If they do fund 27 million, and the fact that the Port of Oakland is involved, a government entity, is going to make this a lot favorable, because one government entity asking another government entity works much better. And I think that's the way we're going to try and do this. But the cost share for the investor would be, if you get 27 million, would be 5 million. Interest cost would be a quarter of a million. And I'm offering this as an investor equity share or as a loan or percent of sales and profit. That those terms can be worked out. Current price of hydrogen is $36 a kilogram. It takes 50 kilowatt hours of hydrogen to produce electricity to produce 1 kilogram of hydrogen. So 2 cents per kilowatt hours gives you $1 per kilogram. But if you have 20 cents per kilowatt hour, then you get a price of $10 per kilogram. And if the interest cost is $1.25 and admin costs for managing the production is $1.25, that comes to a total of $12.50 per kilogram. If we sell it at $25 a kilogram, we can make a profit of 2.5 million. So business opportunities for you are license the technology for a patented hydrogen furnace. Again, the terms can be determined. It will apply for the regular patent, so the licensee will be protected. We can invest in the production and marketing of solar battery cooker and hydrogen generator. I'm estimating to set up production facilities for each would cost estimated $1 million at one of the local West Coast production warehouse type facilities. The return would be percent of sales and percent of profit. You can invest in the project for the production of hydrogen at the Port of Oakland. I said, I have applied, so I have some experience. I had applied for a similar project in the past, but I had done it personally. And unfortunately, on a technicality, I have the funds coming from California more than what they had said. And I didn't quite qualify in that round, but I do have some experience and connections with the California Energy Commission. So again, I would offer an investor equity or as a loan or percent of sales and profit. These are the two of us. There's myself and there's a person who's a hydrogen expert. He worked for almost close to 25 years in Chevron as a hydrogen engineer. He has been helping me, and he's developing the products, and also he's a consultant in the big project. Like I said, I have a PhD in engineering, experience in renewable energy, hydrogen, railway locomotives, and rail transit. I'm also the Chief Technology Officer of Cybertran. I'll just show you a brief slide for that. Developing hydrogen products. I'm a hydrogen instructor. Mr. Walt Pyle has more than 20 years of experience in hydrogen. He has developed small hydrogen products. He introduced understands how to use hydrogen very safely. He's doing research on producing green ammonia, which you take nitrogen plus hydrogen and subject it to solar plus molars. You take solar energy, concentrate it, and to a high temperature, and you combine nitrogen and hydrogen. So anyway, green ammonia is another potential area. Options we can consider that I was going to do it proposed to the port, and they have asked for the details of the proposal, and we'll be providing that to the port. So anyway, we have talked about the investments already. This is the end of my presentation, but I just wanted to show you an innovative rail transit and freight company which can use very lightweight vehicles. The reason why this is cost so less is because the vehicles are very light, much lighter than very heavy transit vehicles, and there's only single vehicle. So the guideways and columns are very slender, and 75% of the cost of these systems is the guideways. So that saves a lot on cost. It can carry freight also, passengers. It can carry vehicles at 3 tons every 9 seconds in an automated mode. In the transit option, of course, in ports, it would eliminate the diesel truck traffic. It has a transit option for future consideration, and it will be on-call direct to destination. It has also a high-speed rail option, which can operate on-call direct to destination, much more affordable than California high-speed rail. I'm estimating we could, if we get funded, we could complete the high-speed rail system, which they keep talking about 2039. We could complete the whole system by 2032 at about 25% of the price. But anyway, this is Cybertran if you want to take a look at it. But anyway, that's basically my thing, and I'm now open to questions that you might want to ask.
Well, thank you so much for the presentation. It was very in-depth. Does anybody have any questions?
What can be some of the steps for us to support your mission in New York State?
Pardon, what was the question?
What can we do in New York State to support your mission?
Are your question about the solar system?
Yes.
Yeah, so the solar system in this case is estimated to need about 38 acres of solar panels. We have another company like Cybertran that is planning to use the area, the outer harbor area that we are thinking of, and it would be much lower cost to mount this. They have a very large facility, so we would be proposing that we work with this company to mount it on the roof of their system and then just use a corner of their building for our electrolyzer and our battery system. And outside, we would have the storage tank and the refueling station just outside the building. So that's kind of, in a sense, the proposed approach. The mechanics still has to be worked out, but we have talked to the company, and the port is open to suggestions like that.
Well, thank you so much again for joining us today. Wishing you good luck, and we'll be in touch.
Thank you.
Pardon? Okay. Should I stop sharing?
Yeah, you
Oh,
can stop
okay.
sharing. Yeah.
Oh, okay.
Thank you again.
Okay, all right.
So
Is
now
that
we're gonna
it?
do a printed version of this interview. We'll do an article, and then we'll send you a draft for approval.
Okay. All
Okay,
right.
good talking to you.
Thank you very much, Shota. It's a real pleasure. And let me know if there's any interest in any party for the business interests. That would be great. I'm open to investors, and this certainly can proceed much faster if investments come in. And I think the potential is great for development and for good business development and good profits. There's a lot of potential. Okay?
Thank you so much. Thank you.
All right. Thank you very much. Thank you, Shota.
Bye. Thank
This has been a
you.
real pleasure.
Yeah.